All right, suppose you got the 1.5 kilogram brick dropped on a glass top from a height of 20 centimeters. What is the impulse necessary to stop the brick? So the first thing you need to identify is the fact that we're dealing with impulse. We can either solve for impulse using F delta T or M delta V. That's the first thing you need to decide. Which route are you going to take? Well, if you're not given times, probably not going to be able to do F delta T. So we need to find out M delta V. How much does its velocity change? Impulse mass final velocity minus mass initial velocity. What's the mass of the object? 0.5 kilograms. And what's the final velocity of the object? The brick is going to fall, and it's going to hit the tabletop. While it's falling down, there's no impulse. What we're concerned with is what the table does to it, because we're stopping the brick. We want to know what force times time or what change in momentum is necessary to stop the brick. We don't care about as it's falling down. Boom. We care about that table and what force it's going to exert. I guess I was a little bit premature to say that there was no impulse. Sure, it's changing momentum on the way down, but that's not what we care about in our problem. We care about stopping the thing. Boom. So what velocity did it start with, and what velocity did it finish with? Spencer said, final velocity is 0 meters per second. It's true, it's stopped. So what velocity did it hit the table with? Kinematics, energy is slightly better. mgh equals 1/2 mv squared, potential equals kinetic, so the result, root 2 gh. Centimeters. 2 times 10 is 20 times 0.2. 20 times 0.2. 4. Square root of 4? 2. 2 meters per second. So when it first hits the table, it's traveling at a speed of 2 meters per second. Then the table stops it. Boom. So what was the change in momentum? 0 minus 3. Why is it negative? Did I do the math? Did I do the math wrong? Yeah, force is acting in the opposite direction of what we've called positive. We're calling positive downwards from our previous math, our 2 meters per second there. So we said that positive was downwards because we use positive velocity, so the change in momentum is upwards. It's the opposite direction of that. If I had changed the momentum downwards, it would have picked up speed. So the force which is causing the change in momentum is up that way, so we expect it will be negative value, whatever it happens to be. Now, could I have said that the velocity was negative too? Mathematically? Yeah, because the square root is a plus or minus. So I could have said negative, and that would end up positive, and everybody had been happier, I guess. But mathematically, it's okay. It's okay that we have negative change in momentum. Momentum's directional, so that's fine. So that's the change. if the brick stops in 0.01 seconds, what's the average force? Well, the relationship between force and change in momentum is impulse, force delta time. Time, 0.01 seconds. Change in momentum is -3 kilogram meters per second. Force is 300 units. Newtons. Negative. Can't be. I hate to magically change that to positive, but if I want force to be positive, then I have to say that its direction is positive. So the up direction is positive. Well, this change was in the up direction positive, so that's okay. I hate magically changing it, but it's better than having negative force, because negative force doesn't make any sense. Part 3, what's the force that the brick exerts on the tabletop? So the tabletop exerted 300 newtons of force on the brick. What did the brick do to the table? (300 newtons of force), according to third law. If I exert a force on something like this table, it exerts a force backwards on me with the same magnitude of force.